Hello, I'm Sergey Levashkin. I'm in charge of the AI lab of Powolsky University of Telecommunications and Information Technologies. I would like to speak about the application of artificial intelligence in business and in production in terms of the future transformation of the future intelligence and getting stronger intelligence. We assume that from now Industry 4.0 we are moving to new Industry 5.0 revolution based on knowledge mining and design of the ecosystem of AI clusters, unlike these contemporary siloed solutions. And this digital transformation is targeted at digitalization and the implementation of AI in management decisions of enterprises, creating smart digital twins that can increase the efficiency of companies' management multiple times. And the change of paradigm of this enterprise management in Society 5.0 transforms business processes, procedures, and people motivation. Another important element of the transformation is the so-called democratic development and creating independence management systems based upon automation of multiple processes with the application of artificial intelligence. The main objective of this transformation would be creating smart enterprise for managing the assets, the so-called smart enterprise, and it should be very personalized for business to address particular goals. And what are the goals? First of all, the development of the concept of the digital twin strong intellect. So this trend goes as follows: everything which is everything that can be digitized will be digitized, and humankind has been tackling this task for the last 50 years. And we need to develop the new concept of the enterprise management based on artificial intelligence. When in the multi-agent environment, artificial intelligence replaces multiple managerial functions and prompt us to get new decisions and find new solutions. Development of open source platform of smart enterprise, smart ERP, development of digital twins, and development of digital ecosystems for enterprise, region, and industry. And I think these contemporary trends need to be taken into account when we talk about digital transformation of our society and the transformation of our activities. In the course of my presentation, I would like to give a definition to what artificial intelligence is all about these days, what's business intelligence all about, and hopefully I'll come up with some examples. I'll be speaking about the trends in different areas. First of all, I would be focusing on the pandemic combat methods, which proves to be one of the most difficult management tasks. I'll be talking about minimizing the damage. This slide depicts two definitions of artificial intelligence today, and I speak about today. It's a set of methods, algorithms, and technologies for processing data of any type. Data of any type, and I would like to highlight this, the homogeneity here is not that important. It's the data that can be processed. It's important that they would be describing some kind of area so that we'll be able to get AI to good use to identify anomalies, come up with classification, clustering, etc. And we we'll be talking about the results of these new AI applications. They are getting more interesting the more the data amount is processed. So it's the so-called big data phenomenon. With the use of business intelligence, we can identify new knowledge and, for example, new equations. I'll come up with a very good example. Tycho Brahe was an astronomer, would be observing the celestial bodies moves. And when he passed away, he left his heritage, his legacy of his logs, and that was big data that he left as an astronomer. The celestial body moves, the orbits the planets, followed by another astronomer, Kepler. Johann Kepler came up with the three famous laws that stipulate the moves of the celestial bodies in the solar systems. Then all that information that we had previously had become obsolete because it could be recovered with just these new three laws. And that's the task for business intelligence, how to pull out new knowledge out of those masses of data. And Kepler was able to do that even without using any computer. Now it's all done with the use of the machines, and the machine is trying to do just the same, to extract some new knowledge out of masses of raw data. Well, I would like to give a definition to business intelligence. In broad sense, it's the process of converting acquired data into business knowledge to make better management decisions. And I'll be speaking about some collective or the so-called ROI intellect. This collective intellect is more easily gets collective. If we have a group of agents, and we put it as agents, the agents that interact in some environment, then the description of such a ROI, such a flock, is more easy to formalize. And the so-called battle robots in a factory can be all served by collective intellect. And I would like to list some formal procedures used for this description. This is all done with a very high uncertainty level. Our human brain makes decisions in the situation of uncertainty. To make sure that we teach a machine to do the same, we're talking about a very complicated process, which is schematically depicted here at this diagram. When we buy something in a supermarket, we may take a decision based upon a multitude of factors. For example, if you take me, for instance, If I decide to buy something, I would like to simulate the same process for a machine. Turns out to be a very challenging task. That's what we call the development of these methods in the areas with high level of uncertainty. That's another thing that we need to take into account in digital transformation. So where can this be applied? So, for example, traffic flow, the crowd behavior, pandemic spreading, the information wars, imitation simulations. For example, the crowd behavior. When we have a conflict, a revolution or something, it could be modeled by the use of this approach, the practical approach, and it's done by special services, by specific organizations that are created to minimize the activities of such events. When we're talking about transformation to 5.0 state, we will be talking about monitoring of information space monitoring. When we select a certain set of databases on the internet, and you get that data from there. But then there is another approach, which I think the future belongs to. This is when you monitor the information space, like the internet, in the unlimited approach. You monitor the entire internet. But to do that, to be able to do that, we need to create a system which is called an associative ontological system, like I call it. When we have to input some filters and we select the information we require from multiple sources. What kind of information? I would like to give you a few examples on automated collection of internet data with 9 positions. We need to have this data to, for example, emulate the containment of coronavirus spreading. The model looks like this. Take a look. This is the particular application. The spread of the coronavirus is emulated here with the differential equations system. It's done by this dynamic system where different factors are taken into account, like susceptible, exposed, and infectious populations are taken into account. Recuperated and recovered patients. N stands for total population size. D stands for mimicking the public perception of risk regarding the number of severe and critical cases and deaths. C representing the number of cumulative cases. It's the reaction of people to pandemic and the reaction of authorities. Apart from those, we're talking about other ones that are related to pandemic. For example, the spreading velocity. But the main thing here is the response of the people to the authorities' actions. We will be talking about theory of complex systems with those dynamic systems I mentioned and equations. We're talking about the monitoring to tune the system up and data mining. As well as that, we need machine learning. Machine learning is required here basically because you cannot resolve that with the classic approach, because that's a very non-linear approach. And you can see there the authorities' activities through this model, and you see the response of population, and these are the results that come out of that. We are toying with these parameters. We identify them with the use of internet monitoring. We apply our equations and set the parameters about contagious individuals on different scales, on different axes, with all those infected, exposed, and even dead. And here you can see what's going to happen if prevention measures and individual protection rules are applied correspondingly, and what happens in the absence of government action, and what is going to happen if people will not comply, and what's going to happen with low compliance with individual protection rules. You see the picture changes drastically, and you will see how many cases will there be with high compliance and how many cases there will be with low compliance. We can plot a few other things here. It's all generated automatically, of course. That's what the machine is doing, and it's identifying all of the management activities or managerial actions output required. What's going to happen if the high compliance is maintained, and what happens with the appropriate government actions? Then we can see that the number of exposed and infected drops. It drops sharply. And you can see that government actions and people's response are two main things. They prevail over other parameters utilized in the model. And that model had been explained by different medical people to us. With deeper analysis of the model, if you drill it down, we can predict the second wave coming. We can estimate how many infected there will be on a certain day. So those who would have to minimize the threat would be prepared, and they will know how many doctors will be required and how many units of medical equipment will have to be used to get ready to minimize that danger. That's my take on the contemporary state of affairs in this very complex transformation as we move to the digital economy or digital society, for that matter, and this notorious Industry 5.0. Thank you very much. You may contact me by the following credentials, and please leave your feedback there if you like. Thanks again for listening.